Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Nvidia. We have Marc Hamilton. How are you doing today, Marc?
I'm doing great, Rich, and great to be here and to talk to your readers again.
Yeah, we're here in Frankfurt. I just watched your talk at the old hot seat or vendor showdown. You did a great job. Congratulations there.
They were a little easy this year, I think.
Yeah, they were. They were pussycats. But let's shift gears here. I wanted to find out what you guys announced at the show with the new GPU. Can you tell me about that?
Sure. So for 10 years, we've focused on a single accelerated computing platform. And hard to believe that it's been 10 years since we launched CUDA, but
10 years,
it's
yeah.
really become part of the key scientific discovery process in HPC centers around the world. And for the last 3 or 4 years, we've seen a tremendous adoption of our accelerated computing platform for sort of new class of AI applications.
Yeah.
If you look when AI first started to, through deep neural networks being used about 4 years ago in 2012, when the ImageNet competition first used GPUs, we had about 200 applications running on GPUs. Since that time, that number has grown to over 400. We're 410 GPU-enabled applications today. In those same 4 years, the number of CUDA developers has grown 4x. So we now have over 300,000 CUDA developers around the world. And as a result, in the machine learning and in deep learning space, 100% of the frameworks for deep learning training are accelerated by NVIDIA GPUs today. So with that as a basis, we launched a couple months ago the NVIDIA Pascal P100 for NVLink enabled servers. That's really our highest performance, strong scaling platform, but we wanted to bring the power of the P100 GPU to all of our current users using all of the different GPU-enabled platforms on PCIe servers from all of the mainstream vendors. And so that's what we announced at the show this morning. We think that there's a real need for this. If you look across Europe, if you look across the US, if you look in Asia, all of the HPC centers today, the numbers of resources that scientists are requesting far outstrip the available compute capacity. These big systems. And what that really means, for instance, for the National Science Foundation in the US is that 2 out of 3 scientists don't have the compute resources that they need. And so we're trying to address that by building ever more powerful GPUs, but also enabling the building of strong nodes. Think of a strong node as a server with 4 or even 8 GPUs in it. And by concentrating more performance inside the server, you use fewer numbers of servers, and then you're reducing the cost of all your infrastructure. And so not only does your total budget decrease for the same level of performance, but it lets you solve these strong scaling apps. Applications like Amber that just don't scale using so-called weak nodes or CPU-only nodes. So let me share some details on the P100 for PCIe-enabled servers. This GPU has everything that the Pascal for P100 for NVLink servers has, except, of course, the NVLink. So it's built in an industry standard PCIe card, just like all of our previous GPUs, and fits in basically any GPU-enabled server in the world. So a lot of people ask us to compare the performance versus earlier generations of GPUs. And of course, the performance varies by application because it's a brand new GPU. We're just starting to do benchmarking on it, but we showed a number of apps here that show great scalability, not just from 2 K80s to 2 P100s, but also the scaling between 2 P100s to 4 P100s. So again, across a wide range of apps, not only in deep learning, but also across a broad variety of HPC application domains. So let's take a look at a typical HPC center and pick 2 codes that they might run. Of course, every HPC center today is starting to attract deep learning workloads, and the Caffe AlexNet benchmark is a typical one that data centers run. On the HPC side, on those same exact nodes, we're probably going to want to run an HPC code. VASP is one of the recently converted to GPU codes in the material science space. And again, here, even with 32 CPU only or weak nodes, you still can't reach the performance of a single strong node with 8 P100 GPUs. So let's sort of equate that to dollars and cents with your budget. So again, not only is that gray area in the circle, or that infrastructure cost going down because you have so many fewer nodes, but again, the total cost of the budget, of your budget is going to go down. Of course, because you're adding GPUs to the node, the individual server is going to become more expensive, but you have fewer servers and fewer infrastructure. So we asked some of our customers on this slide that were early users, beta users of Pascal. So it's great that actually Andrew Ng actually spoke, gave his keynote today, and actually one of the things that he said is that strong scaling is really, really hard to do. And they're using strong scaling with up to 8 GPUs and classic HPC technologies like high-speed interconnects to advance their deep learning work. Shifting over to the traditional HPC side, we went to our largest GPU customer here in Europe, Thomas Schulteis at CSCS, the Swiss National Supercomputer Center, and he's really looking forward to getting his Pascal upgrade, which he's right in the process of doing today. And of course, not only are all of the traditional x86 vendors shipping P100 later this year, but also IBM will be putting the GPUs, the Pascal GPUs, into Watson. So just to recap all the specs, in the top here we have the Tesla P100 for NVLink-enabled servers. This is on our new SXM2 form factor, which exposes the NVLink interface on the bottom of the card, which you see there. And then you see the traditional PCIe form factor, P100. Again, the only two differences between these are NVLink being available on the top. Because we wanted to go for the broadest possible server adoption, we went with a 250-watt power form factor for the PCIe card. So that has slightly lower performance scaled with the clock rate, but it's the same exact GPU inside. So that wraps it up for what we introduced this morning with the P100 for PCIe-enabled servers.
Okay. I guess the big question I have is when does this GA? When will people be able to get their hands on the new P100 for PCIe servers?
So we're sampling now to OEMs, and it will ship in Q4 of this year for most OEMs. We expect a few OEMs may get products out in Q3, but broad availability across all of our OEMs in Q4.
Oh, great. Well, Mark, I know you've got a lot going on this week, and I appreciate your time. So thanks for coming on the show today.
Great. Thanks, Rick.
All right. That's it for the Rich Report, folks. We'll see you next time for more news and information on high-performance computing.